Hey there, science fans! Today, we're diving into the fascinating world of metals and nonmetals. Everything around us is made up of elements, and these elements can be broadly classified as metals or nonmetals. How can we tell them apart? It's all about their properties. Metals are like the superheroes of the periodic table. They are typically shiny, strong, and great conductors of heat and electricity. Think of a sturdy iron bridge or a copper wire carrying electricity to your home. These are the amazing abilities of metals. Nonmetals, on the other hand, are quite different. They are not as shiny, and they don't conduct heat and electricity very well. Many nonmetals are gases at room temperature, like oxygen, which we breathe. Others, like sulfur, are brittle solids. So metals are like the strong, conductive heroes, while nonmetals have their own unique set of properties. Now, let's learn more about each of them. Metals are truly remarkable. One of their most noticeable properties is their shine. Think of a brand new gold coin or a sparkling silver spoon. That's the metallic luster, and it's because metals reflect light in a special way. Metals are also known for their strength. They are usually solid at room temperature, except for mercury, which is a liquid. You can find metals used in buildings, bridges, and vehicles because they can withstand heavy loads. Another cool thing about metals is their ability to be molded into different shapes without breaking. We call this malleability. Imagine a blacksmith hammering a piece of iron into a horseshoe. That's malleability in action. Metals are also ductile, meaning they can be drawn into thin wires. This property allows us to have electrical wiring that carries power throughout our homes. Pretty neat, right? Let's talk about how metals behave in the world of chemistry. One key characteristic is that metals tend to lose electrons in chemical reactions. They're like the generous friends who are always willing to share. When metals lose electrons, they become positively charged ions. These ions are what allow metals to conduct electricity so well. The electrons flow freely through the metal, like a stream of tiny charges. Metals can also react with oxygen in the air to form metal oxides. This process is called oxidation, and rust is a common example. Think of an old bike left out in the rain. The iron in the bike reacts with oxygen, forming rust, which weakens the metal. Remember, metals are the sharers of the periodic table, always ready to give up electrons in chemical reactions. This generosity is what makes them so important in many different applications, from batteries to electronics. Now let's explore the world of nonmetals. Unlike shiny metals, nonmetals can be dull, meaning they don't reflect light in the same way. Think of a piece of coal or sulfur. They lack that metallic luster. Nonmetals are also not as good as metals at conducting heat or electricity. In fact, many nonmetals are good insulators, meaning they resist the flow of heat and electricity. That's why we use materials like rubber or plastic to insulate electrical wires. Unlike malleable metals, nonmetals tend to be brittle. This means they break or crumble easily when subjected to force. Think of a piece of chalk snapping in two. That's its brittle nature. Nonmetals can exist in all three states of matter at room temperature. Oxygen and nitrogen are gases, bromine is a liquid, and sulfur and carbon are solids. When it comes to chemical reactions, nonmetals play a different game than metals. Instead of losing electrons, nonmetals tend to gain electrons, becoming negatively charged ions. They're a bit more reluctant to share their electrons compared to metals. This tendency to gain electrons makes nonmetals good at forming compounds with other elements. For example, chlorine, a nonmetal, readily reacts with sodium, a metal, to form sodium chloride, which is common table salt. Nonmetals are also essential for life. Oxygen, a nonmetal, is crucial for respiration. Carbon, another nonmetal, forms the backbone of all organic molecules, including DNA and proteins. So while nonmetals might not be as shiny or strong as metals, they have their own unique properties that make them essential for our world and our very existence.